Good day, esteemed researchers and viewers worldwide. We're thrilled to present our paper, Multi-modal Learnable Queries for Image Aesthetics Assessment, by Jiwei Shang, Yunfan Zhang, Jide Shen, Peiran Ren, and Han Yu. Our research addresses the challenge of unpredictable performance in image aesthetics assessment when limited user comments are available. We introduce a novel method, the MMLQ, that efficiently extracts multimodal aesthetic features. Stay tuned to learn how this method outperforms existing ones and our plans for future enhancements. In this slide, we delve into the key highlights of our research. Our primary motivation is to enhance image aesthetics assessment, or IAA, by efficiently extracting multimodal aesthetic features. These features are derived from both images and their associated user comments, providing a richer understanding of the aesthetic value. We also address a significant issue faced by existing multimodal IAA methods. These methods often exhibit unpredictable performance when only a limited number of user comments are available. This is a crucial problem, as user comments provide valuable insights into the aesthetic perception of images. We've observed that performance degradation occurs with fewer user comments, which could be attributed to a sentiment mismatch between the selected comments and the overall sentiment of all comments. This highlights the importance of considering all perspectives in IAA, as everyone's opinion matters in assessing aesthetics. In the next slides, we will discuss our proposed solution to these challenges. Stay tuned. Moving on to the key highlights of our research. We've developed a novel approach called the Multi-modal Learnable Queries, or MMLQ method. This method uses learnable queries in conjunction with frozen image and text encoders. The purpose: to efficiently extract multimodal aesthetic features from images and their associated user comments. But here's the twist. We're aiming to overcome existing limitations by not relying on explicit corresponding user comments during inference. This opens up new possibilities for the application of our method. Stay tuned as we delve deeper into the workings of this innovative approach. Begin a frame title at key highlights, begin itemize, item key contribution, begin itemize, item. We've introduced a new approach to image aesthetic assessment, IAA, called the Multimodal Learnable Queries, MMLQ method. Item. This method is designed to efficiently extract and process multimodal aesthetic features from images and their associated user comments. Item. Our MMLQ method has shown significant improvements in performance on multimodal IAA tasks, outperforming existing state-of-the-art methods. End itemize, end frame. In this slide, we're highlighting the key contributions of our work. We've developed a novel approach to image aesthetic assessment, which we call the Multimodal Learnable Queries, or MMLQ method. This method is unique in its ability to efficiently extract and process multimodal aesthetic features from images and their associated user comments. The results have been impressive, with our MMLQ method showing significant improvements in performance on multimodal IAA tasks. In fact, it has outperformed existing state-of-the-art methods, demonstrating its potential for further development and application. Moving on to the key highlights of our research. The main idea revolves around our proposed method, the Multimodal Learnable Queries, or MMLQ. This method utilizes learnable queries in conjunction with frozen visual and textual encoders to efficiently extract aesthetic features from input data. Now, let's delve a bit deeper into the method sketch. The visual and textual learnable queries are designed to learn aesthetic features through a three-step process. First, they pass through a replaceable self-attention layer. This layer allows the queries to focus on different parts of the input data based on their importance. Next, they go through a separate multimodal cross-attention layer. Here, the queries interact with corresponding pre-trained visual and textual features, allowing them to extract more nuanced aesthetic features. Finally, the queries are further processed through a replaceable feed-forward layer. This layer helps in refining the features extracted by the queries, ensuring that the most relevant aesthetic features are captured. In essence, our MMLQ method provides a robust and efficient way to extract aesthetic features from multimodal data. Stay tuned as we delve deeper into the results and implications of our research in the following slides. Begin a frame title at key highlights, begin itemize, item. The Multimodal Learnable Queries, MMLQ, method was proposed, using learnable queries with frozen image and text encoders to efficiently extract multimodal aesthetic features. Item: the MMLQ method has shown significant improvement over existing IAA methods on the AVA dataset with user comments from the AVA Comments dataset. Item: despite its success, MMLQ has a limitation. Its performance can be unpredictable when only a limited portion of user comments are available. Item: future research will address this limitation by incorporating additional submodules based on aesthetic-aware image-to-text retrieval or image captioning. End itemize, end frame, .. Let's delve into the heart of our research, the multimodal learnable queries, or MMLQ, method for image aesthetics assessment as shown in the figure. This innovative approach uses learnable queries with frozen image and text encoders to efficiently extract aesthetic features from images and their associated user comments. Now, what is image aesthetics assessment, or IAA? It's a method to evaluate image quality based on human perception. It's not just about pixels and resolution, but about how humans perceive and appreciate the aesthetics of an image. IAA has gained significant attention recently, especially in the fields of image aesthetic enhancement and aesthetic-aware text-to-image generation. These applications are becoming increasingly important in the era of social media and digital content creation. In the next slides, we will explore how our proposed MMLQ method outperforms existing methods and sets a new benchmark in the field of IAA. Stay tuned. Let's delve deeper into our proposed solution, the multimodal learnable queries, or MMLQ, method for image aesthetics assessment. As you can see in the figure, this method learns and processes both visual and textual aesthetic features to estimate the aesthetic distribution of opinion scores, or DOS, of an input image. Now, the challenge in IAA lies in its inherent subjectivity. The standards of image aesthetics are not fixed, but rather, they are determined by the varying opinion scores from different reviewers. This subjective and ambiguous nature of aesthetics makes it a challenging task. However, our MMLQ method aims to tackle this challenge by efficiently extracting multimodal aesthetic features from input images and their associated user comments. This approach allows us to capture the diverse sentiments expressed in the comments, which can provide additional aesthetic guidance. Let's delve into the heart of our research, the multimodal learnable queries, or MMLQ, method for image aesthetics assessment. As you can see in the figure, this method learns and processes both visual and textual aesthetic features to estimate the aesthetic distribution of opinion scores, or DOS, of an input image. Now you might wonder, why user comments? Well, they play a crucial role in IAA. They not only provide additional aesthetic guidance, but also express strong inherent sentiments that are beneficial for IAA. Imagine comments with words like phenomenal, magical, or blurry. These words carry strong sentiments and can greatly influence the aesthetic assessment of an image. So, in essence, our MMLQ method leverages these user comments along with the image itself to provide a more comprehensive and accurate aesthetic assessment. Stay tuned as we delve deeper into how this method outperforms existing ones. Let's delve into the heart of our research, the multimodal learnable queries, or MMLQ method for image aesthetics assessment. As you can see in the figure, this innovative approach learns and processes both visual and textual aesthetic features to estimate the aesthetic distribution of opinion scores for an input image. However, it's important to acknowledge the limitations of existing IAA methods. They often face unpredictable performance when only a limited number of user comments are available. As the number of user comments decreases, the performance tends to degrade. This could be due to a sentiment mismatch between the selected comments and the overall sentiment of all comments. Remember, in IAA, every opinion matters. In the next part of our presentation, we will discuss how we plan to address these limitations in our future research. Stay tuned. Begin a frame title at the MMLQ method. A closer look, begin a figure, centering include graphics, width equals 0.8 text width, height equals 0.45 text height at SRC, task _ execution extracted _ paper _ data, 2405.013226v1, figures, 2405.013226v1 figure 2:1.png, captiona tinea detailed workings of the multimodal learnable queries, MMLQ, method for image aesthetics assessment IAA, end figure, begin itemize. Item unpacking the MMLQ method, begin itemize. Item MMLQ uses learnable queries to extract aesthetic features from images and user comments. Item the method involves a multimodal interaction block with self-attention and cross-attention layers. Item the learnable queries are processed through these layers to extract and refine aesthetic features. Item the method has shown superior performance on the AVA dataset, outperforming existing IAA methods. End itemize. Item future directions, begin itemize. Item despite its success, MMLQ's performance can degrade with fewer user comments. Item future research will aim to address this limitation by incorporating additional submodules. End itemize, end frame. Begin frame. Frame title a multimodal interaction block. Begin a figure, centering, include graphics, width equals 0.8 text width, height equals 0.45 text height, a SRC, task underscore execution extracted underscore paper underscore data, 2405.01326v1, figures, 2405.01326v1 figure 3:1.png, caption a tiny illustration of the multimodal interaction block, MMIB, in the MMLQ method. It shows the process of extracting aesthetic features using learnable queries, LQs, through a series of self-attention and cross-attention layers. End figure, begin itemize. Item the multimodal interaction block, MMIB, begin itemize. Item MMIB uses learnable queries, LQs, to extract visual and textual aesthetic features. Item LQs are processed through self-attention, SAW, and cross-attention, CA layers. Item FFeed, forward FF layer is added to further process the LQs. End itemize, end frame, begin frame. Frame title a multimodal interaction block. Begin a figure, centering, include graphics, width equals 0.8 text width, height equals 0.45 text height, SRC, task underscore execution extracted underscore paper underscore data, 2405.01326v1, figures, 2405.01326v1 figure 3:1.png, caption a tiny illustration of the multimodal interaction block, MMIB, in the MMLQ method. This figure shows how visual and textual learnable queries are processed through self-attention and cross-attention layers to extract aesthetic features. End figure, begin itemize. Item the MMIB in detail, begin itemize. Item learnable queries extract aesthetic features from images and comments. Item self-attention and cross-attention layers process these queries. Item feed forward layer further refines the queries. End itemize, end frame. Moving on to the related works in the field of image aesthetics assessment, or IAA. The early attempts at IAA were characterized by the development of handcrafted features. These features were designed to correspond to photographic rules that were easily understandable by humans, and these rules were often summarized by professional photographers. However, these early attempts had their limitations. The photographic rules that were used may not have been able to cover implicit aesthetic patterns that are present in images. Furthermore, these implicit aesthetic patterns are often difficult to summarize using human language, which posed a significant challenge. In the next slide, we will delve into how these challenges have been addressed in more recent works. Begin frame. Frame title our contribution. The MMLQ method. Begin itemize. Item we introduced the multimodal learnable queries. MMLQ method. Item MMLQ uses frozen image and text encoders to extract multimodal aesthetic features from images and user comments. Item our method significantly outperforms existing IAA methods on the AVA dataset. Item future work includes addressing limitations by incorporating aesthetic-aware image to text retrieval or image captioning. End itemize. End frame. Begin frame. Frame title limitations of current IAA methods. Begin itemize. Item despite their performance, multimodal IAA methods like MMLQ have limitations. Item performance can be unpredictable when only a limited portion of user comments are available. Item performance degrades as fewer user comments are available, possibly due to sentiment mismatch. End itemize. End frame. Begin frame. Frame title a multimodal pre-trained features. Begin itemize. Item we use a frozen pre-trained vision transformer, VIT, to process images into visual token embeddings. Item user comments are encoded into token-level embeddings using a frozen pre-trained text encoder. Item both visual and textual features are crucial for the MMLQ method. End itemize, end frame. Begin frame. frame title are related works, begin itemize, item efficiency of learnable queries, begin itemize, item R method, the multimodal learnable queries. MMLQ is an efficient solution to extract relevant aesthetic features. It uses frozen image encoders to process images into patch tokens and visual token embeddings. End itemize, item additional aesthetic guidance from user comments, begin itemize, item. The MMLQ method also utilizes user comments associated with the images. These comments are encoded into token-level embeddings using a frozen pre-trained text encoder. This approach allows us to extract multimodal aesthetic features, providing additional aesthetic guidance. End itemize, end a frame, begin a frame title our proposed method. Multimodal learnable queries, MMLQ, begin itemize, item R method uses learnable queries to extract multimodal aesthetic features from images and user comments. Item we employ a frozen pre-trained vision transformer to split images into patch tokens and a CLS token, creating a collection of visual token embeddings. Item user comments are encoded into token-level embeddings using a frozen pre-trained text encoder. Item these visual and textual learnable queries first go through a replaceable multi-head self-attention layer. Item they then extract aesthetic features from pre-trained visual and textual features through a separate multi-head cross-attention layer. Item finally, a replaceable feed-forward layer is added to further process the learnable queries. End itemize, end a frame, begin a frame title are related works. Begin itemize, item limitations of existing methods, begin itemize, item the need for additional pre-training on aesthetic attributes. This can be time-consuming and resource-intensive. Item performance degradation for images without dominant attributes. This means that the method may not work as well for images that don't have a clear aesthetic focus. Item unpredictable performance when only a limited portion of user comments are available. This can make the results less reliable. Item performance degrades as fewer user comments are available. This means that the method may not be as effective if there are not enough user comments to analyze. Item mismatch in sentiment between the randomly selected comments and all comments. This can lead to inaccurate results, as the sentiment of the comments is a crucial factor in aesthetic analysis. End itemize, end a frame. Moving forward, let's delve deeper into the technical details of our proposed research. As you can see in the figure, the overall structure of our multimodal learnable queries, or MMLQ, method is illustrated. This method is designed for image aesthetic assessment, or IAA. The MMLQ method uses visual and textual learnable queries, or LQs, to learn aesthetic features. These LQs go through a replaceable self-attention layer, a separate multimodal cross-attention layer with corresponding visual and textual pre-trained features, and a replaceable feed-forward layer. The averaged visual LQs and the averaged textual LQs are then concatenated and fed into linear layers, followed by softmaxed to output the estimated aesthetic degree of satisfaction, or DOS, of the input image. In essence, the MMLQ method adopts learnable queries with frozen image and text encoders to efficiently extract multimodal aesthetic features. This approach has shown to be highly effective in our experiments. In the next slides, we will discuss more about the specific components of this method and how they contribute to its performance. Moving forward, let's delve into the technical details of our proposed solution, the multimodal learnable queries, or MMLQ method. As you can see in this figure, the MMLQ method uses visual and textual learnable queries to extract aesthetic features. These features are obtained through a replaceable self-attention layer, a separate multimodal cross-attention layer with corresponding visual and textual pre-trained features, and a replaceable feed-forward layer. The averaged visual and textual queries are then combined and processed through linear layers, followed by softmax to estimate the aesthetic degree of satisfaction, or DOS, of the input image. Now let's talk about the problem we're addressing. There's a significant need for a method that can effectively handle situations where only a limited number of user comments are available. Our MMLQ method addresses this issue by extracting aesthetic features not just from images, but also from their associated comments. This dual extraction allows for a more comprehensive understanding of the aesthetic value of an image, even when user comments are scarce. This approach is what sets MMLQ apart and allows it to excel in image aesthetic assessment, or IAA. Moving on to the technical details of our proposed research, let's delve into the structure of the multimodal learnable queries, or MMLQ method, as depicted in Figure 2. This method is designed to efficiently extract aesthetic features from images and their associated user comments. At the heart of this method are the visual and textual learnable queries, or LQs. These LQs are essentially learnable embeddings that are shared among samples. They are designed to extract aesthetic features from pre-trained visual and textual features, respectively. The process begins with the LQs going through a replaceable self-attention layer. This layer is designed to improve the training stability and can be shared among multimodal LQs or separated based on modality. Following this, the LQs extract aesthetic features through a separate multimodal cross-attention layer. This layer is different from the self-attention layer, as keys and values are constructed from the pre-trained visual or textual features. Finally, a replaceable feed-forward layer is added to further process the LQs. This layer comprises two linear layers, a JLU activation, and an add and norm procedure, similar to the self-attention and cross-attention layers. In summary, the MMLQ method is a robust and efficient approach to extract aesthetic features from images and their associated user comments. It's a significant step forward in the field of image aesthetic assessment. On this slide, we delve into the technical details of our proposed method. The Multimodal Learnable Queries, or MMLQ, for image aesthetic assessment, as shown in the figure. This innovative method uses learnable queries to extract aesthetic features from images and their associated user comments. The experiment design is also outlined here. We evaluated the MMLQ method using the benchmark AVA dataset, supplemented with user comments from the AVA comments dataset. We also examine how the performance of MMLQ changes when different portions of user comments are available during inference. This approach has shown promising results, outperforming existing methods. However, it's important to note that the performance can vary when only a limited portion of user comments are available. This is an area we plan to address in our future research. In this slide, we delve into the technical details of our proposed multimodal learnable queries, MMLQ method. As you can see in the figure, the MMLQ method uses visual and textual learnable queries, or LQs, to extract aesthetic features. These LQs first pass through a replaceable self-attention layer, which allows the model to focus on different parts of the input. Then, they interact with pre-trained visual and textual features through a separate cross-attention layer. This layer enables the model to understand the relationship between the visual and textual data. Finally, a replaceable feed-forward layer further processes the LQs. The output of this process is the estimated aesthetic degree of satisfaction, or DOS, of the input image. This method allows us to efficiently extract multimodal aesthetic features from images and their associated user comments, outperforming existing methods on the benchmark AVA dataset. In the next slides, we will discuss our future research plans and how we aim to tackle the limitations of our current approach. Moving on to our technical results, let's take a look at the figure on the right. These are example results from the test set of the AVA dataset using our MMLQ method. The blue and green numbers below each image represent the predicted and ground truth aesthetic mean opinion scores, MOS, respectively. Now let's delve into the key results. Our MMLQ method was rigorously evaluated on the benchmark AVA dataset, with user comments provided by the AVA comments dataset. The experiments revealed that MMLQ significantly outperforms existing state-of-the-art image aesthetic assessment IAA methods. What makes MMLQ stand out is its extraordinary performance in IAA. It efficiently extracts multimodal aesthetic features from images and their associated user comments, providing a comprehensive understanding of the aesthetic value of an image. However, it's important to note that while MMLQ shows promising results, it does face a limitation. Its performance can degrade when only a limited portion of user comments are available. This is an area we plan to address in our future research. Stay tuned for more updates on this exciting journey. Moving on to our technical results, let's take a look at the example results on images from the AVA dataset using our MMLQ method. The blue and green numbers below each image represent the predicted and ground truth aesthetic mean opinion scores, respectively. Now, let's delve into our ablation studies and their implications. We observed that the performance of MMLQ varies when different portions of user comments are available during inference. Interestingly, as fewer user comments are available, the performance of MMLQ tends to degrade. This could be attributed to the mismatch in sentiment between the randomly selected comments and all comments. This limitation, however, opens up an exciting avenue for future research. We believe that incorporating additional submodules based on aesthetic-aware image-to-text retrieval or image captioning could potentially address this issue. On the right, you can see a visual representation of our results. This figure illustrates the effectiveness of our MMLQ method on the AVA dataset. In summary, our MMLQ method shows promising results, but there's still room for improvement and further exploration. Begin a frame. Frame title a future work and limitations. Begin itemize. Item future directions. Begin itemize. Item plan to address limitations by incorporating additional submodules based on aesthetic-aware image-to-text retrieval or image captioning. Item these submodules will not rely on explicit corresponding user comments during inference. End itemize. Item limitations. Begin itemize. Item MMLQ's performance can be unpredictable when only a limited portion of user comments are available. Item performance degrades as fewer user comments are available, possibly due to sentiment mismatch between selected comments and all comments. End itemize, end itemize, end frame,